Hello everyone, welcome back again to my YouTube channel, and in this video we will solve second HashMap question of our series. And in this series we are solving just 10 HashMap question, and this will help you in getting good hold of like HashMap concept, and you will be able to solve complex questions also of HashMap that will be asked in the interviews. And now let's start quickly. And in this video we will also learn about like elimination strategy, which will be used to optimize solution. I will tell you the intuition behind it, and basically I call it elimination strategy that I have personally learned to optimize the solution. So stay tuned and let's start with our question. Okay, so so this is our question. Okay, so I'm just going on this question. So this was the question, and when it was asked in the interview, any question like asked in the interview, there are three things that you need to do. One is like understanding question, telling approach, and third one is like coding it. Okay, so first one is understanding here. So this question is quite clear from the description itself, right? It has like a very small description, so it's quite clear. So in this question basically we have to find longest substring without a repeating character. So longest substring is a part of a string which is continuous. Okay, so here for example, let's see what will be answer here. So one string can be ABC, right? And when you include a, then a will be duplicated, so that's why you cannot include a. And you have to find longest also, right? So that's why you want to include more character, as many as character you want in a string, in a substring. So here answer till now is ABC. Then if you see again BCA, this can also be one of the answer. And then if you see CAB, okay, so C is duplicated, so that's why cap can also be one of the answer. And BCB, no, so BC can not be the answer because its length is 2. So it's quite clear, like answer is ABC and output is that's why 3. And there are many substring with this max length having unique characters. Now so question is quite clear, and now comes our second thing. So here second thing is our solution, right? So in the solution what we will do is, so the first thing that comes in our mind, let's try to formulate that. So as when I was explaining also, I was doing this kind of a thing, right? I was checking every substring, right? So I was checking basically every substring and then trying to find out whether it has all distinct character or not. So for example here and for checking every substring we can do a nested loop, right? So we will do a nested loop for every substring, so that will be n square. Now let's see what can be the complexity. So first approach and then its complexity, and then only we will be able to tell whether this is a brute force. If we are able to find out optimized approach with better time complexity, then this naive approach will be our brute force. So here one thing we can, so I'm just summarizing my approach in 1-2 lines now again, my thought process. So what I'm doing here is I'm checking every substring and checking whether it has unique characters or not. And to check every substring it takes n square, and then there are various approaches to check, right, whether that substring has all unique characters or not. So one approach can be again inside this I'm just writing one very naive approach is again like using nested loops. So I can check for occurrence of, for example, I have this ABC as a string, right? So what I can do, I can pick first character and check whether that occurs in this string or not. Similarly, I can do for each character whether there is another occurrence of that character or not, right? For example, you will pick B and then you will check whether that B is in that substring or not. For example, if it's a, right? So then if you pick A, then you will check in entire string whether there is an occurrence of A or not. So that's why in that way, using two nested loop, again you can find out whether it has all distinct character or not. So overall complexity here is n to the power 4. And one more thing while I was explaining you comes in my mind is like to check whether a character occurs previously or not, right? So there is a very good data structure to do this kind of a searching and updating, and that is HashMap or HashSet, right? So if you want to find out whether a character occurred previously or not, you can put the characters in HashSet or HashMap, right? Here HashSet will also work because you just need to check whether that exists or not. So what you will do, you will put A in the HashSet. I'm just like creating again this approach ABC. So this is like to check whether that substring is all unique characters or not. So here you can put that into hash set. So A you will put into hash set. So insertion is order 1, searching is order 1. So that's why overall time complexity will be order n, because you just need to iterate this entire substring. So this can be like n cube. Okay, and this overall approach can be n to the power 4. Okay, so these are the things which came in my mind first. So you can discuss this approach with your interviewer first and get his opinion whether you should try to optimize it or not. Now let's think whether we can optimize it or not. So here comes our strategy, which I called it like an elimination strategy. So for example, if you see closely observe here, so you have A, B, C, right? And then again you have A. Now to reduce time complexity, definitely you have to reduce operations. For example, here what I'm doing is I'm trying to find out every substring. So somehow I have to reduce this. So then only you will be able to reduce the overall time complexity. So here A, B, C, and then again A comes. Now if you try to eliminate possible answers, you can definitely say any substring which starts before the previous indices of this A, right? So previous A was here, right? So I'm just copying it here to explain you better. So if you see this string, right? So it's clearly observable from here is, if you see any substring which starts from whose starting point is before this A, previous occurrence of this character, then they cannot be our answer, because those all string will have like double count of A. For example, I'm just putting out some random character to explain you better, X, Y, for example, right? Now when you will come to this point, this A, then you have 1, 2, 3, 4, 5 as a like longest substring till now, and once you include this A, then it cannot be our answer, because it has like a duplicate A. And also all the substring starts from whose starting point is before this A. For example, this one, okay, V, A, B, C, A, this cannot be our answer, right? So there is no need to check for substring starting with indexes before A and going beyond this A, right? So that's why there is an approach called sliding window and 2-pointer approaches here. So you can adjust your window. For example, let's understand this closely. So here, if you observe closely, if you have a pointer, right, then you don't need to consider any substring starting before A. So that's why you can just consider cases which starts from this point onwards, because this possibility you have already explored. All the substring which starts before A, right? That possibility of exploration is already done. So now remaining part is this only. So that's why here approach comes in of like 2-pointer also. If you maintain 2 pointers left and right, then you can check which window has unique character, and you can keep count of maximum length of that window. So now let me just summarize my approach. So in just 1-2 lines. So I will keep 2 pointers left and right, and I will keep on incrementing my right window till I encounter a duplicate occurrence of any character. Okay, and once I encountered a duplicate occurrence of any character, I will move my left pointer to a point beyond that character, beyond the occurrence of first occurrence of that character. Okay, so for example, here my left and right starts from X, okay, and then my right go beyond here. So now when my right reaches A and my left reaches X, then I have a duplicate occurrence of A. So that's why I will keep moving my right, and then my left will come at this point, and then again I will start searching, right? And I will keep on updating my max answer also. So in this way you will be able to solve this in order n itself, right? Because each character you are just visiting 2 times in the entire iteration. Although it will have like 2 kind of a nested loop, but overall time complexity will be order n, and I will explain you how that is an order n solution, right, while I will code. So it's quite hard to predict that in first attempt, but yeah, I'll try to explain that in the while I'll code. So now approach is clear. So once you have done like explanation of this approach to your interviewer, now let's start coding. So also I have like coded a brute force approach here, which you can check later, but now for now I'm just coding the optimal approach. Okay, so I'm just removing all of these things. Right, so now let's code the thing out. So here I'm just coding the optimized approach. Okay, so I'm just initializing first of all length, because I will use this a lot of times. So this is s, and now if n equal to 0. So these are some like boundary cases, right? I don't want to proceed on this front, so I will simply return 0. No length is possible. Now I'm just initializing character set. So it will basically help me in determining if in that window there is a duplicate, if some characters occurred or not, and it will do the searching, insertion, deletion, and insertion, searching and deletion in order 1. So that's why I'm using HashSet for optimization. And let's introduce our answer to be like max length, and it will be 0 for now. Okay, and now left point, as I said, I will initialize a left pointer, and right pointer I will do in a loop. So for right, now I will start moving my right pointer to like end of the indexes. So range function is there in Python, which will help you in like iterating from 0 to n minus 1. So this is yo, and now again a nested loop. So when this nested loop, you will see nested loop, you will tell like time complexity at order n square, right, if asked, but it's not. That I will explain why it is not, and in last I will explain why it is just order n, and it's quite tricky and asked in many interviews. Okay, so what I'm doing here is, while when I moved my right pointer, I'm just checking whether that character is in my set or not. For example, for our case of x v a b c a, right? So when my right pointer, suppose my right pointer is here a, right? So I want to remove all this character from my hash set, and I want to move my left pointer to this point, right, b. I want to move it to b. So that's why I'm just trying to delete all the characters here. So character underscore set dot, so it's remove, and it's again order 1, and I'm just removing as of the character name and its left pointer. So I'm removing all left, because I need to remove all of those, not just a. So I remove this, and I will equal to 1. I'm incrementing my left pointer, and then once this is done, now I will add my right pointer here, the element which is at right pointer, and I will also update my answer, okay, for each position. So max underscore, so it doesn't suggest anything, so equal to max of max underscore length comma right minus left plus 1. So this will be your length, right, if your right and left pointers are at some particular position. And for finding out this, you can just like try to manipulate few cases also. For example, if your right pointer is at this point, right, so right pointer movement 0 1 2 3 4 5, right, and your left pointer is at 3, so your length will be 5 minus 3 2 plus 1. So that's why it's 1, because we are storing the length. And then once this is done, I will return my max length. Okay, now let's try to run. Most probably it might give some compilation error. Okay, indentation in line number 51. Okay, okay, it's accepted, and then I'm submitting it again. Okay, so it's done, right? So it was accepted. Okay, so now let's come to the third most interesting part, which is like time complexity. So here, if on like first observation, if someone asks you like time complexity, then people will say there is a for loop and then there is inside again a nested loop, right? So that's why its time complexity is n square, but that's not the case here. So if you think smartly and if you see overall for a string, for example, let's see the string whatever. So now if you see in the entire iteration, each character is visited only twice in entire code. Each character is visited twice only, right? So that's why the overall time complexity, if you see of this combined for and while loop, it's 2 into n. So that's why it's order n solution. Okay, and space complexity is obviously order n because we are just having a store. Okay, so in this video we have learned like the elimination strategy that you have to use to reduce the time complexity, which things cannot be the answer of your solution while thinking of an approach, and you can discard that part, and in that way you can optimize it. So you have learned how to use HashMap, hashset, and also sliding window and the elimination strategy to come from brute force, which was like n cube and 4 to order n solution. So this is overall order n, so it's quite optimized solution. And yeah, this all was the learning. Feel free to put comments and subscribe to my channel because I'm going to put more interesting questions ahead. Okay, bye, have a nice day, happy coding.